Hello everyone and welcome back to exercise number 37 of the SolidWorks basic tutorial series. In this video, we're going to be designing a tapered mounting hub. Now, as always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, but for this component, we're going to be using the Revolve Boss Base tool very heavily. In fact, to create the main body of this component, we're going to be using the Revolve Boss Base tool. Here we see the schematic drawing for exercise number 37. All dimensions are in millimeters. Here we see the isometric view, the top view, the section view, and this section view was taken along this horizontal line here, section AA. And we have a number of detail views, 3 in total. For detail B, it showcases the details for the tapered hole at the top, of course, showcasing all the dimensions. For detail C, we see the opening, or in fact, the holes on the baseline of the component. And for detail D, it showcases the dimensions for this opening here at the bottom. All right. So, of course, we have a question here for this exercise, and it reads, what is the mass of this part in grams? And it requires us to use the ASTM A36 steel. All right, so by the end of this video, we're going to determine the mass of the part in grams. And before we actually determine the mass of the part, and after designing the part according to the dimensions shown, we're going to have to assign a material of ASTM A36 steel. All right, so what are the main features for this component? Here we see that we have a base flange for this part. In addition, we have a central boss or hub. Of course, this central hub is both stepped and tapered, as shown here in the figure. We have 8 mounting holes. In fact, we can see this very clearly on the top view. 8 mounting holes on the base flange of the component. The dimensions for these mounting holes are showcased in detail C. And we have a section view. Of course, this section view is very important. Actually, to model this within SolidWorks, we're only going to be using one 3D feature, and that is the Revolve Boss Base tool. So to model this very efficiently in SolidWorks, we're going to sketch out the section profile. And since we have symmetry for the component along the y-axis, we're going to sketch out this profile right here using the line tool. And after that, we're going to fully define the sketch according to the dimensions shown. Of course, in defining the sketch or in drawing the sketch, we're automatically going to create the counterbore feature that runs along the center of the component. All right. After we sketch this profile and then use the Revolve Boss Base tool to create the main body for the component, we're going to move on to the other steps, which is to create the mounting holes on the base flange. And we have to create these 8 tapered holes on the top surface of the component. Again, for that, we're going to use the hole wizard in addition to the circular sketch pattern tool. All right. Finally, we're going to work on creating this notch here, this opening. And for that, we're only going to create one of it. And we see here that this notch is situated on a center line or line that is 25 degrees with respect to the horizontal. Okay. And we have a number of dimensions here. So yeah, that's basically it. So with that aside, let's get started with exercise number 37. Okay, so let's start by creating a new SolidWorks part. We set the background to plain white, and we copy exercise number 37 into SolidWorks. Okay, so as I said previously, the easiest way to model this within SolidWorks is to sketch out half of the section profile for the component, and then use the Revolve Boss Base tool to create the main body. So to begin, select front plane, sketch, and go ahead and select center line. And starting from the origin, draw a vertical center line. Now this center line here corresponds to the center line for the counterbore feature. So this line here indicates the center along which the component will exist. Now what we need to do is select line and sketch out the profile, half of the section profile for the component. So let's go ahead and just sketch this out. I'm not doing anything fancy here. I'm just simply sketching out the lines here. All right. Okay, now we select Smart Dimension, and looking at the figure here, the dimensions here that define the sketch for the section profile, we see that the distance between this top edge and this bottom edge is 160 millimeters. So the distance between this edge and this bottom edge should be 160 millimeters. All right, let's just enlarge this image here. All right, now the distance, select Smart Dimension again, and the distance between this edge and this bottom edge is 125. So distance between this edge, this outer edge right here, and this bottom edge should be 125. Let's drag this downwards. All right, select Smart Dimension again, and the thickness of this edge should be 16. And the distance between this line and this line should be 20 millimeters. The radius of the circle should be 10 millimeters. And looking here, we see we need to just drag this to the other side here. All right, select Smart Dimension again. And let's define certain angles. We see that the angle between this line and this line is 160. And the angle between this line and the horizontal is 120, right? So the angle between this line and this edge is 160 degrees. The angle between this line and this line should be 120. Again, we need to just drag out and fix certain features for the components. Okay, now select Smart Dimension again, and we see the distance between this line and this bottom line should be 50. Drag this upwards. It's important that we maintain the basic profile for the section view here while defining it. And we see that the distance between this line and this line should be 50 millimeters. Likewise, the distance between this edge and this edge should be 60 millimeters. And the distance here, we see from this point to this point, half of it should be 100. So since it is 200, so the distance between this edge and this point here should be 200. Should be 100. And we have the final dimension here between these two extreme points here, 230, right? So the distance between this point and this point should be 230 divided by 2. Let's just drag this here. Okay. Now select Smart Dimension tool again, and the distance for the length of this edge should be 30 millimeters. Right? And what else do we have? Yeah, we have distance between this edge and this edge should be 20 millimeters. And we have an angle between what and what. We have an angle of 100 degrees between this inclined line and the horizontal as 100 degrees. So in this case, the angle between this edge and this horizontal edge should be 100 degrees. All right, and we have a distance, an overall distance between this point and this edge. This is defined by the radius of the base flange. We see that it's 205 millimeters, right? So this should be 205 millimeters. Okay, now we look at the drawing here and see if we've missed any important dimensions. We have the angle between this line and this horizontal line as 100 degrees, right? And let's set the ratio between this point and this point as horizontal. All right. Now I think we fully defined the sketch. Let's just make sure, let's double check. We've used all of these dimensions. We've used 20, 160. We've used, we need to define, select Smart Dimension again. The distance or the length of this edge should be 60 millimeters. All right, so we use 50, 30, 100, 20, 125, 100. Okay, I think we've fully defined the sketch now. There's nothing left for us to do. Just to make sure, the length here should be 90. And the horizontal distance between the center line and the center of the circle should be by default. Yeah, now the sketch is fully defined. All right. So now we can move on to the next step, which is to go to Features, Revolve Boss Base. And we can see here, we see a preview for the Revolve Boss Base operation. Let's go ahead and select OK. So this creates the main body for the component. Now we need to move on to the next step, which is to create the mounting holes on the base flange. So let's go ahead and select this top face, Sketch, select Circle, and starting from the origin here, let's draw one larger circle. Now this circle represents the pitch circle, basically helping us to determine the position of the mounting holes. So select this circle and convert it into a construction geometry. Right? Select Smart Dimension, and we can see here that this construction geometry should have a diameter of 360 millimeters. So the diameter of this circle should be 360 millimeters. Now select Circle again, and let's go ahead and draw one of the mounting holes, starting from this top edge. And we have a detailed view for the mounting holes. We have 8 of them. The diameter for each hole should be 17.5. So select Smart Dimension, and the diameter of this hole should be 17.5. All right. Now select Circular Sketch Pattern Tool. And here's for the entities to pattern, select this circle. By default, the number of copies is set to 4. We need 8, so let's go ahead and change that to 8. And then select OK. Now press S on your keyboard, select Extrude Cut. And we're going to cut these 8 profiles all the way to the other side of the component, and then select OK. So that creates the 8 mounting holes on the base flange. Now we're going to create the tapered holes on the top face here. So go ahead and select this top face, Sketch, and let's go ahead and draw the pitch circle to situate the tapered holes. So starting from the origin here, let's draw a circle. Let's convert this circle into a construction geometry, and let's define the diameter of the circle. And from the figure here, we see that it should have a radius of 80 millimeters. So that corresponds to a diameter of 160 millimeters. Right? Now, go to Features, Exit Sketch, select Hole Wizard. And here we see a detailed view showcasing all the necessary dimensions for this taped hole. So the type of hole that we should select is taped hole, the straight taped hole right here. And we're going to use the ISO standard. And we're going to set the size for this hole as M14 by 1.5. So this should have a pitch of 1.5 millimeters. Now we need to define the depth of this hole as 36 millimeters, as indicated right here. So now go to Positions, and then select this top face. Now we're just going to position this circle right here on this point. And then select OK. So that creates one of the taped holes on this top surface. We need to repeat this now 7 times, right? In total, there are 8, but there needs to be 7 other copies. So let's go to Linear Pattern here and select Circular Pattern. Here's going to ask you for the direction for this circular pattern. Go ahead and select this outer edge. And by default, it's already set to 8, and then select OK. Right, now let's select this line and set it as height. We don't need this line anymore. Okay, so now we're almost done. We just need to create this notch or this opening on the base plate. So select this face, Sketch, select Line, and we're going to draw 2 lines. One horizontal line, starting from the origin, of course, and another inclined line at any angle like this. Okay, and we need to define the angle between these 2 lines as 25 degrees. Now, these 2 lines will help us draw out the profile for one of the notches here, and we see here that the angle is situated at approximately 25 degrees with respect to the horizontal. Now, what we need to do is simply select this top face and then select Convert Entities. And that will create a solid sketch out of the circumference of this larger circle. Now let's select Offset Entities. And we're going to offset this inclined line at a distance of 30 millimeters in each direction, right? So then select 30 and select bidirectional. Go ahead and select this line and then select OK. Select Trim Entities and go ahead and delete any extra lines that you don't need. So we need this line. Now let's draw a line starting from this point to this point. Select Trim Entities and delete any extra points that you don't need. Let's delete this partitioning line. Select Smart Dimension. And set the distance between this line and then this point right here as 30 millimeters. All right. Now select Trim Entities and delete this partitioning line here. Click OK. So that creates the profile for the notch here. Now we just need to fill certain edges. Use the fillet tool, and from the figure here we have a fillet radius of 10 millimeters for each of these two vertices, vertex 1 and 2. And then select OK. Now press S on your keyboard, Extrude Cut, select this sketch right here. Let's just delete this line right here. Just go normal. Let's delete this line. Trim Entities and delete any extra lines here. Okay, so press S on your keyboard, Extrude Cut, and by default it already selected the profile that we just created, and then select OK. So that creates one of the openings for the base plate. So to repeat that, simply just select Linear Pattern and then select Circular Pattern right here. It's going here, ask us for the direction, select this outer rim, and set the copies as 8. We can see a preview right here, and then select OK. So now we need to define the material for this component. Again, we need to answer the question, what is the mass of this part in grams? So we go here, right-click, Edit Material, and we need to select ASTM 8036 steel, and this is the option right here. Apply, close. Let's delete this edge. Now let's determine the mass of this part. So go to the Evaluate tab, select Mass Properties, and here we have an answer of 38,586.5. 38,586.5 grams. That is our final answer. Okay, so that concludes exercise number 37. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. I hope to see you all in exercise number 38. Until then, bye-bye.